everyone. In this screencast, we want to talk about union and intersection. And once again, we use some examples using dice and using cards. So, for union and intersection, let's consider this example. Consider rolling one die. As we talked about before, the sample space for rolling one die is 1, 2, 3, 4, 5, and 6. Those are all the different possible outcomes that could come out from rolling a fair die. You're being asked to find the probability of rolling a number divisible by 3 or odd, and rolling a number divisible by 3 and odd. These are two different questions. Let's look at them separately. So, if we want to find the probability of rolling a number divisible by 3 or odd, or rolling a number divisible by 3 and odd, we have two different events. The two events are rolling a number divisible by 3 and rolling an odd number. So, let's think about these two events. If we want to find the probability of rolling a number divisible by 3 or odd, this is the proper notation. Remember, this is the symbol for or. And if we want the probability of rolling a number divisible by 3 and odd, this is that proper notation. It's the upside down U. Remember, the right side up U means or, and the upside down U means and. So, if we're going to be rolling a number divisible by 3 or odd, let's think of all those possible outcomes. So, we need to look at those separately. How many different ways can we roll a number divisible by 3? Well, there are two numbers in this sample space that are divisible by 3, the number 3 and 6. What about rolling an odd number? There are 3 odd numbers in our list, 1, 3, and 5. So the probability of rolling a number divisible by 3 or odd is if I would roll a 1, a 3, a 5, or a 6. Any of those outcomes would satisfy the condition of being 3 or odd. So there are 4 possible outcomes out of 6, or 2 and 3. The probability of rolling a number divisible by 3 and odd is different because at the same time it has to be divisible by 3 and be odd. There's only one number in that list that is divisible by 3 and odd. That's the number 3. So the probability of event 1 and event 2 is 1 in 6. There's a formula that you should remember for this that will help you do these kinds of problems. For any events A and B, the probability of A union B is equal to the probability of A plus the probability of B minus the overlap of the two. Now that's going to help us in this next question. Make sure you write this down. This is definitely one of those equations you want to have memorized for the quiz when you sit down to take your Chapter 8 quiz. Suppose you are selecting a card at random from a standard deck of cards. You want to find the probability of choosing an ace and a heart, and then separately choosing an ace or a heart. These are two different questions. So we're going to call event 1 the event that we choose an ace, and event 2 is choosing a heart. The probability of E1 choosing an ace is 4 out of 52. There are 4 aces in a 52 card deck. So that probability is 1 in 13. And the probability of event 2 choosing a heart is 13 out of 52 because there are 13 hearts in a deck of 52 cards, or that probability is 1 in 4. So what's the probability of choosing an ace and a heart. So let's think about that. How many ways can we get an ace and a heart? So remember from the sample space, we want an ace and a heart. There is only one ace of hearts in this deck. So the probability of choosing an ace and a heart is 1 out of 52. There is only one ace of hearts in this deck. All right, the second question was, what's the probability of choosing an ace or a heart? So the probability of choosing an ace, remember, was 4 out of 52. The probability of choosing a heart is 13 out of 52. Using that formula that I want you to memorize, which is the probability of event 1 or event 2 happening is the probability of event 1 plus the probability of event 2 minus the probability that they happen at the same time. So this is the probability of choosing an ace plus the probability of choosing a heart minus the probability of choosing the ace of hearts, because you don't want to count that twice. So that probability is 4 out of 52 plus 13 out of 52 minus 1 out of 52, which comes out to 16 out of 52, or 4/13, and that is approximately 0.3077. I hope that helps clear up any questions you might have in these sections. Feel free to email me if you need a little bit more help.